All right, college algebra. Now we go over the second part of our lesson 3, and we're going to do attack. We're going to be going over a few items you might have been a little rusty on, but are very important for moving forward. So here we have the the product of two binomials, and what is a binomial? Binomial is a Greek prefix and suffix, bi meaning two, nomial mean names. And so here we've got binomial number 1, binomial number 2. And note that they have 2 parts. And if it was a trinomial, right, it would have 3 parts, right? So pretty straightforward there. So when we multiply these through together, it can be useful to break it up into steps. And so first we're going to be multiplying the A by C plus D. And then we're going to multiply the B by C plus D. And then we distribute the A to both terms, and that gets us AC plus AD. And then B times C, that's going to be B times C, and then BD. And that's it. That's how you multiply through. If you wanted to do it in one step, you could just go A to C, and then A to D, B to C, and then B to D, and that would hit everything, whichever one you want to do. So A times C, A times D, right? AC, AD. Then we have B times C, B times D, BC, BD, right? Everything's accounted for. Whichever way you feel more comfortable, that is the way you should do it. Now, more often the binomials we'll come across will be where x is one of the terms inside. So we have x plus a, and then we have x plus b. So using the same steps that we did before, we have x times x plus b, and then we have a times x plus b. And then we go through here, x times x, x squared, and then we've got b times x is the next one up, and then we have here plus ax plus ab. And go down a little bit further. We're going to group these two together, and so that we have x squared plus a plus bx plus ab. And so note that what we have here, whenever you have two binomials, we have an x here. In order to get the middle term, you add these two together. To get the constant term over here, you just multiply these two terms together. Now, another expression you're going to be coming across a lot of times might be something that looks like this, where we have ax plus b times x plus c. And just as a reminder, A, B, and C, these are just stand-ins. Like they'll just be numbers that you would see, like 2x plus 3 multiplied by x plus 8, for instance. And so we're just doing this in the general so that we can use that to our advantage formulaically. So going through this again, in order to use what we got before, I can factor the A out of the first term so that it becomes like what we saw before. Right, note that if I distribute this a to both terms, this would become ax, and b over a times a just becomes b. And now I've got simply two binomials similar to what I had here before. And so when I multiply through, I have an a, we do big parentheses, and so x squared plus, so I add the two terms together, and then b over a times c would be that last term there. Now we just distribute the a across the board here, and we get ax squared plus b plus ac, multiply that by x, plus b over a times c, multiplied by a. The a's cancel out, so that just leaves me with bc. So note that the two terms here are still multiplied together to get this term here. The only difference is that the middle term is just this b plus, yes, still the second term, but you got to multiply the second term by whatever's in front of the x. And so that's a nice little shortcut you can get through. There's any number of ways. You don't have to use this formula if you don't feel comfortable doing that, but it is useful to know that it's there. So let's work a couple of examples here. First, we want to expand x plus 3 times x plus 1. And so x times x, of course, that is x squared. Remember, we add these two guys together. So that gets us 3x. I'm sorry, not 3, 4x. And then 3 times 1, that is, of course, 3. And there it is. Just that simple using the formula. If you're not comfortable with that, we could just go back to going to all the terms, right? And so we go x times x plus x times 1, right? So we've got x squared plus 1 times x. And then we do 3 times x. And then we do 3 times 1. Which will again get us x squared plus 4x plus 3, right? Whichever way you feel more comfortable working this problem, that's the way you should do it. All right, so next one, x plus 2 times x minus 3. So again, you just do x squared, and then we would add these two together, so that's a negative x, and then multiply them together, and then that would be a negative 6. Right, pretty straightforward when you do it that way. All right, moving on. So now we are going to be looking at expanding the binomial a plus b squared. Now, I want to make a very, very important note, and it's a mistake that a lot of people make. If you have the expression a plus b quantity squared, it absolutely does not equal a squared plus b squared. Okay, so this is not a mistake you want to make, so make sure that you don't make it. But what does it mean if I have a plus b squared? Well, that just means that I've got a plus b multiplied by itself, right? So I have a plus b times a plus b, just like so. And this looks pretty similar to what we were doing earlier, where we have a times a plus b times a plus b again, right? I'm just distributing this term to here and to here. That's all I'm doing. And so this again becomes a squared plus ab plus ba plus b squared, right? Distributing the a to both terms, a squared, ab, and then over here, ba, bb, right? That's how we got b squared. So AB plus BA, that's the same quantity, so we rewrite this as A squared plus 2 times AB plus B squared. And that's how you get that expression right there. So moving forward, what about A minus B quantity squared? So we could work through this again. We can also just use what we had above, just replace B with negative B. And so we have a squared plus 2a negative b plus negative b quantity squared. And that is a squared minus 2ab, and negative b squared is just positive b squared. And so there you go. And so note that the only difference between this top expression and bottom expression is that the middle term is positive here, but negative right there. So let's look at one other expression. Let's look at x plus a quantity squared. Well, again, that is x plus a times x plus a. And it will simply be x squared plus 2ax plus a squared, because again, it's the first term squared, and then the last term squared, and then plus 2 times the product of these two terms. 2 times the product of these two terms. Okay, good. So, moving forward, why don't we look at one other that would be of interest to us? What about when I have ax plus b quantity squared? Because this does come up. And so again, this is simply ax plus b times ax plus b. And so we distribute this ax plus b to both terms, just like we did a second ago. And so we've got a times ax plus b plus, I'm sorry, ax, there we go, plus b times ax plus b. And then we distribute this across, and we have a squared x squared plus abx, and now we do this one, bax plus b squared. So this becomes a squared x squared. And note that these two just combine, 2abx plus b squared. And so we've got another useful expression right there. All right, so we've got a couple examples here. We want to simplify 2 plus 3 quantity squared. First by adding the numbers and then squaring the result, and B by using the formula above. So 2 plus 3 quantity squared is the same as 5 squared, or simply 25. Now if we use the formula above, 2 plus 3 squared equals 2 squared plus 2 times 2 times 3 plus 3 squared. And so running through this, we got 4. 2 times 2 times 3, 2 and 3 is 6, 2 and 6 is 12. And then, of course, 3 squared is 9, so 9 and 4 is 16, 16 and 9 is 25. So you see, the formula works. We get the same result either way. Now let's move on to the next, where we expand x minus 5 quantity squared. And that is simply x squared plus 2 times 5 times x plus 5 squared. All I'm doing is just applying the formula. And so this is x squared plus 10 times x plus 25. And there you have it. That is the way that is done. So now let's talk a little bit about conjugates. Conjugates are a pair. They're defined as being a pair. So they are a pair of binomials that have numbers of the same magnitude, but one number has the opposite sign than in the other binomial. So for instance, the conjugate of a plus b is a minus b, right? Note that this minus is the only thing that changes. So what happens when we multiply a pair of conjugates like we have right here? So again, we've got a times a minus b plus b times a minus b, right? I'm just taking this and distributing it to both terms. And there's nothing that says I couldn't distribute a plus b to both terms in the other direction. That is perfectly fine to do as well. So when we do this, we get a squared minus ab plus ba minus b squared. Notice these two are the same. Actually, they have the same magnitude, but they have opposite sign. Negative ab plus ab is 0. So the result here is simply the difference of squares, a squared minus b squared. So this will be something that we use quite a bit. Oftentimes we'll see it where it looks like this, x plus a times x minus a. And when you multiply those together, we get x squared minus a squared. So this is something that we definitely want to remember. So let's do a couple of examples now. What is the conjugate of x plus 3? Well, that would be x minus 3. And now we're to find the product of this pair of conjugates, so x plus 3 times x minus 3 would be simply x squared minus 9, right? X squared minus 3 squared. Okay. Next example, we're given the difference of squares, and now we want to break it into a pair of conjugates. Well, note that x squared minus 25 is the same as x squared minus 5 squared. And now that we have that, we know that this should be x plus 5 times x minus 5. And that's it. That's how you find the get back to the pair of conjugates when you're given the difference of squares.